All right, so today we are going to talk about kind of putting all of the pieces together. So what we're going to do is we have a polynomial equation up top here, and then we have the corresponding graph that goes along with it. So the reason why both of those parts are important is because we need to be able to tell the roots of our polynomial in order to kind of answer the questions down below. So when we are looking at this polynomial expression here, we are going to start by looking at the degree. So the degree, again, if you don't remember, is going to be in standard form the highest exponent. So here we have an x to the fourth. So that means that we have a degree 4 polynomial. Okay, and then these next pieces follow along. So if we know we have a degree of 4, we know the number of roots needs to be 4. So these two numbers will always match, and then we're going to use the graph to answer the next two parts. So let's just make a note here. These two are answered with the graph. So we're going to look and see the number of real roots would be the number of times it crosses the x-axis. So we have 1, 2, 3, and 4. So we know we have 4 real roots, which means we have 0 imaginary roots. So the way we know that is the total number of roots needs to be these two added together. So 4 plus 0 gives us our 4 from over here. Okay, and then the next question asks us our integer x-intercepts. So what it wants to know there is where does it cross exactly? So that's going to be this root here, which is at -1. And it crosses again exactly over here, which is at 2. And then the factors that correspond with that are going to be x plus 1, because -1 plus 1 is 0, and x minus 2, because 2 minus 2 is also 0. So now what we're going to do is we are going to find the remaining roots. The way we are going to do that is we are going to use our polynomial division. So our note underneath here, we're going to divide our original polynomial by our roots. Okay, so I'm going to use as much space here as I can, so I'm going to scroll over. So it doesn't matter which root you start with, so let's just go ahead for this one. Let's start with the x plus 1. So we have x plus 1, and then hopefully I have enough space here. We are going to stick our original polynomial underneath there, so we have x to the fourth minus x cubed minus 5x squared plus 3x plus 6. Okay, so remember this x to the fourth is going to go in our top box here, and then we're going to work our way around. So x to the fourth divided by x gives us x to the third, and then x to the third times 1 gives us x to the third. But we want negative x to the third, so we need to take away 2x to the thirds. Okay, so we have negative 2x squared times x gives us negative 2x cubed. And then down here we have negative 2x squared. But we want negative 5x squared, so we need negative 3x squared, which gives us negative 3x on top and negative 3x on the bottom. Okay, but we want positive 3x, so that means we need to add 6x to that, which gives us a 6 on top and a 6 on the bottom. So what's special about these types of problems is when we get to the end, we need to have no remainder, because we know that these roots go in exactly. We know that it should be divisible by the factor like exactly. So now what we have is we have a polynomial with a degree of 1 less than what we started. So now we have a degree of 3 instead of degree of 4. And then what we're going to do from there is we are going to divide it by our next root. So we're going to do another problem where we're going to divide by x minus 2. So we're going to take our answer from here, divide it by our second root, and then it should give us another polynomial of a lesser degree. So we're going to have x minus 2 and then on the bottom we're going to stick our answer from the last one. So we have x cubed minus 2x squared minus 3x plus 6. Okay, and again, we're going to kind of work our way through here. So we start with our x cubed in the top, which gives us an x squared. So x squared times negative 2 gives us negative 2x squared, which is actually what we want. So we don't need any more x squareds, which gives us a 0x on top, which gives us a 0 on the bottom. And let's just squeeze our x in there just so we can kind of keep it straight. So we want negative 3x's, so we need to subtract 3x, which gives us a negative 3 and a positive 6. Again, because we're dividing by a root, it's a good thing that we have no remainder. So now what we know is that our last roots can be found by using our top answer here. So we know that this polynomial is going to give us the answer to our next roots. So what we're going to do is we're going to set that equal to 0, and we're going to solve. So you can either use quadratic formula, or this one, since we have no x terms, we can actually just use our algebra. So we're going to add 3 on both sides. And then to get the x by itself, we square root. So we know that x is going to be a positive or negative square root of 3, which gives us 2 more roots. So added to our 2 original roots, we have 2 more roots. So that gives us our final answer. So what I like to do at the end is just to kind of make sure that we kind of wrap it up here. So our roots are going to be at the points negative 1, 0, 2, 0, square root of 3, 0, and the negative square root of 3, 0.